Hello students, this is module 6.1.2. This is about vertebrates, and it's about the group of vertebrates that are called the jawless fishes, or superclass Agnatha. So let's start by talking about the third subphylum under phylum Chordata. Remember, the previous two were known collectively as the protochordates and included subphylum Urochordata, the tail chordates, and Cephalochordata, the head chordates, the tunicates and the lanceolets respectively. This is the third and the final subphylum of the semester, subphylum Vertebrata, and this indeed, Vertebrata, the etymology means having the backbone. And so these are the animals with the backbone. And so CN is common name, and this includes the familiar animals, including the fishes, amphibians, reptiles, birds, and mammals. This is a group to which humans belong, as we are mammals. These animals may be terrestrial, aquatic, and even aerial, whereas both the birds and the bats have evolved the ability to create lift and to fly. These animals have a backbone, a vertebral column, and this is a feature for which the subphylum is named. They all have an endoskeleton, either of cartilage or of bone. And if you know anything about the formation of skeletons, first it's cartilage, and then that cartilage becomes ossified, or we have a deposition of calcium salts, which becomes bone. These animals typically have a head with a brain, and the brain is protected in a bony case called a cranium. In some alternative taxonomic schemes, this group is called the Craniata, named after the cranium rather than after the vertebral column. These animals are segmented. Humans are segmented. We have segmentation in our muscles, and we'll show you that in some of the different groups. And also a distinct developmental pattern is seen here. I'm going to give you an overview. I don't mean to shock you by showing you these names all at once, but it's good that you know the magnitude of the task in front of you, that you need to learn this. Fortunately, when you look at it, you'll see that many of these names are familiar names. So let's take a look at the taxonomy of vertebrates. So kingdom Animalia, phylum Chordata, and subphylum Vertebrata. Of course, there are two other subphyla, and that's what this little aside is addressing, the Urochordata and Cephalochordata that are there. But we're only going to look at subphylum Vertebrata, and underneath subphylum Vertebrata, we further divide this into three superclasses. Superclass Agnatha, that has one class underneath it. Superclass Pisces, that has two classes, or twice as many as the previous one underneath it. And superclass Tetrapoda, which has four classes, twice as many as the previous one underneath it. And if you look at the names, the first half looks pretty unfamiliar and kind of daunting. But the second half, Amphibia, Reptilia, Aves, Mammalia, that doesn't look so bad. Those names look somewhat familiar. Here is a simple family tree. It shows ancestral echinoderms. Down here gave rise to the living echinoderms, including the starfish. And then the ancestral chordates, and we're getting more and more fossils of these. They're finding some great fossils right from this time period in China right now, and we're learning more about the evolution and the origin of vertebrates than we knew previously. But there are three lineages which are extant or living. Extant is the opposite of extinct, and these include the Urochordata, the tunicates, the Cephalochordata, the lanceolets, and then the vertebrates, and all these various groups that we see here. They make fishes simpler than they really are here, and we're going to do a little more than that, but not that much. So the important thing to recall here about vertebrates is that vertebrates are derived from invertebrates. And of course, this is evident because protochordates are invertebrates classified into phylum Chordata, the same phylum as that contains the vertebrates. Now, the living protochordates are not direct ancestors of vertebrates. No one thinks that vertebrates are derived from lanceolets and from tunicates, but some are similar in form to those ancestors that gave rise to the vertebrates. And we can go back, go back and look at this family tree and see, we don't think that the tunicates that are alive today gave rise to these guys, but back here there were some ancestors, and they were somewhat similar in form to the tunicates and lanceolets, as you can see there. There is an interesting thing, and I know that most people have experienced this, that we do have a close association between two systems, the digestive and respiratory systems. For example, we're one of the few groups of animals that can end up trying to eat corn and end up with that corn in our lungs instead of our stomach. So that's a close association between those two systems. And it is believed that this resulted from the use of pharyngeal gill slits for filter feeding by the protochordates. And I'll show you what we mean here. Here is one proposed scheme of the evolution of vertebrates. This is after Alfred Sherwood Romer is the guy's name. And this scheme is basically still kind of believed to be how things happen. There are a few updates and whatnot, but notice that this is based on two things: one, real fossils, and two, hypothetical stages that we believe probably happened. The hypothetical stages have asterisks, and there are 3 of them there. But so we believe that there was a primitive sessile arm feeder, and that's very similar to, we have some forms that are alive today, sessile arm feeders, and this is similar to sea lilies, the primitive echinoderms. And so these two are in existence. Now we think that there was a shift from arm feeding to gill filter feeding. Now this is one of those hypothetical stages. We don't have a great representative yet, but who knows, we might find the fossil tomorrow. But we do know that there is a group of worms, the acorn worms, which are in the same group as the pterobranchs. These are 2 groups of invertebrates. They're in the same phylum that we didn't study. In any case, so there was this filter-feeding ancestor, we think, and it gave rise to the tunicates. And so this is actually showing the tunicates with a tadpole larva and then a sessile filter-feeding form, and that's the tunicates that survive today. Now, what is hypothesized to have happened was that, at least in one lineage, back at the time when the vertebrates were originating, was that the swimming filter-feeding tadpole larva did not settle and reabsorb its tail, but rather it continued to swim. Now, lest you think that this is improbable, there actually is one class of tunicates who does exactly that today, whose larva is swimming and becomes sexually mature. And so to hypothesize that that also happened in the past and gave rise to the vertebrates isn't very far-fetched at all. And so all that had to happen was that animal didn't settle down and it became a primitive filter-feeding vertebrate. Okay, and we can see that Amphioxus, by the way, is the genus in the lanceolets. I'm not making you learn that. And so there's a few technical names on here you didn't need to know. But this is just one hypothesis. Does anyone know that this is absolutely true? No, it's just a hypothesized course of events. So now let us look at our first group of vertebrates. And this is under superclass Agnatha. So whenever you see a level of taxonomy, you should think, where does that fit into the whole taxonomic hierarchy? Remember, above this is Kingdom Animalia, phylum Chordata, and then subphylum Vertebrata, and under subphylum Vertebrata, superclass Agnatha. Now, we are going to use the same words, Agnatha, for both the superclass and for the class. Now, in fact, there is an alternative name for the class, but we're going to just use the same class. That's the way it used to be a couple decades ago, something like that. But in any case, we're going to do that for ease of naming here. So superclass Agnatha and class Agnatha, and these will have the same features. Of course, the word Agnatha has the same etymology. Nath, G-N-A-T-H, means jaws, and A means without. So this means jawless. So this group includes animals known as lampreys and hagfish, and collectively we call these the jawless fishes. So the jawless fishes are found here. And so the features are the same for both superclass Agnatha and for class Agnatha. And these animals are aquatic and fish-like. They're actually long and kind of eel-like almost. They have no hinged jaws. They have no paired fins. They have no scales. They often retain the notochord as adults, and they have a two-chambered heart. And so this is the features of superclass Agnatha, and it includes the lampreys and the hagfish. We're going to just look at the lampreys as an example of this group. Now, many lampreys are semi-parasitic, and they feed on bony fishes. Now, what happens is a fish is swimming around in the day, but the nighttime when a fish has to rest, it becomes quiescent. Fish don't have eyelids, so they just settle down to the bottom. And along comes this eel-like lamprey and attaches. This shows the mouth here in the upper right of a lamprey, a round mouth with a sucker and with hooks, and there's a tongue in there, and that tongue has teeth on it. So they attach with that sucker to the side of that fish. As you see here in the lower right, we can see one hanging off the back and one who's attached to the gills, and they attach, and then they use their tongue to rasp through the body wall, rasp, and then they suck out the juices and the blood and tissue from that. Now, I should point out that it says many are semi-parasitic, others are free-living, and they just bury their tails and kind of feed like a lancelet in the Cephalochordata. Down here, this actually shows the larva that grows up to be a lamprey, and in this case, the larva has a particular name. It's called an Ammocetes larva, and this is a filter feeder like a lancelet. They bury their tails. The life cycle of these animals is that the adults live in large bodies of water, either in the ocean or sometimes in lakes, and when they reproduce, they swim up streams, up tributaries, where they will spawn, and then the young are born. The young will stay up in the streams while they filter feed and become larger. And when they become larger, they swim down, and then they will take up their semi-parasitic lifestyle, if that's the mode of their species. I do want to mention to you at least one occurrence, and that is think of let's do some jaywalking like the Jay Leno show. What's the name of the river that separates the northeastern United States from southeastern Canada? So what river makes up the boundary between the United States and Canada in the east? Well, that's the St. Lawrence River. And there is a natural, of course, the St. Lawrence River is a river that drains the Great Lakes. And if you want to remember the Great Lakes, just think of home, H-O-M-E, H for Huron, O for Ontario, M for Michigan, and E for Erie, and actually think of Holmes, and S for Superior. There you go. There's all five of them. In any case, there's a natural barrier that prevented lampreys from reaching the Great Lakes, and that is, of course, think of a place where people often go for their honeymoon, and that is Niagara Falls. This natural waterfall on the St. Lawrence River prevented lampreys from ever reaching the Great Lakes. In the Great Lakes, there was a huge fishery. If you've ever seen the Great Lakes, they're large bodies of water. They have waves, and you can't see the other side. It's huge. In any case, people used to fish for lake trout there, and they'd pull out tons of lake trout every year. And then it was decided that we would want to have large ocean-going ships come up the St. Lawrence River and go into the Great Lakes. But to do that, they had to go around Niagara Falls. And so we dug a canal called the Welland Canal. And for the first time ever, ocean-going ships were able to reach the Great Lakes. But also, for the first time ever, we had disturbed a natural barrier. and lampreys were able to reach the Great Lakes, and they attacked the lake trout fishery. This is a lake trout right here, and a year or two after the introduction of lampreys, the harvest of lake trout precipitated. It just fell. And, of course, it was fisheries biology to the rescue. Biologists looked at the life cycle of the lamprey and looked at where it was vulnerable to control. And they calculated that you couldn't go out into the deep water and find the lampreys. You had to get them when they were going upstream to spawn. And so they actually, this is true, it sounds like science fiction, they put electrified grids across these tributaries and electrified many of the adults. In addition, they also used chemical larvicide so that those adults that did get through the grids and did spawn and the young were up there filter feeding, they actually put chemicals that would kill those larvae, the Ammocetes larvae. And they actually brought it somewhat under control, but the lake trout fishery is not as good as it was before, but it's recovered somewhat from the severe hit that it took. And we're going to conclude this module right here.